Today we are going to talk about the chemistry unit test review. I have written some stuff down and I'll go over them and I'll continue writing afterwards. The first topic I want to cover today is families. The first family we will take a look at is alkali metals. The examples are lithium, sodium. Then we are going to look at alkaline earth metals, calcium, magnesium. These metals have a tendency to lose electrons. The next group or the next family is halogens. Halogens consist of fluorine, chlorine. These are examples. They are the most reactive group. They have a tendency to gain electrons. The next group or the next family is called noble gas or inert gas. The examples for these are neon, helium. They have a stable octet. They do not want to react. They're happy on their own. They have complete shells. The next topic I want to look at is double bonds. So for double bonds, when metals react with nonmetals, we call them ionic bonding. When nonmetals react with nonmetals, we call them covalent bonding. Usually we encounter double bonds and triple bonding when we talk about covalent bonding. So what are covalent bonds? They are sharing electrons. For ionic bonding, they are known as permanent change or permanent exchange of electrons. Moving on, the other thing we have to look forward to when we're talking about double bonding is the capacity. So the capacity to undergo the bonding or reaction. When we look at the example for carbon, carbon has 4 valence electrons. So it can form up to 4 bonds. Carbon dioxide, on the other hand, it has one carbon atom and 2 oxygen atoms. Each of these oxygen atoms can make up to 2 bonds. However, together they can make up to 1 double bond. And when we look at the carbon, it has a capacity to do up to 4 bonds, but in total, 2 double bonds. Moving on, we have energy levels. So for energy levels, the first energy level or shell, it can hold up to 2 electrons. Now the key word here is up to, meaning that's a maximum. Energy level, so the second energy level or shell can hold up to 8 electrons. The third level or shell can hold up to 18 electrons. And the fourth final shell can hold up to 32 electrons. Next, we move on to bonding versus lone pair. Bonding pair are the pair of electrons that are involved in the particular bond. So in our case, the example is NF3. So we have the central nitrogen atom, which is single bonded to 3 fluorine atoms. Each fluorine atom has valence of 7 electrons in its last shell, so it can do up to single bonds. Fluorine does 1 single bond each with nitrogen, and the electrons that are part of this bond are called bonding pair of electrons. The 2 electrons above nitrogen are called lone pairs, and they are not part of the bonding pair. They do not take place in the reaction or the type of bond. We move on to boiling and melting point. The first thing we have to remember is periodic trends. Second thing is based on bonding itself. So is it ionic or is it covalent? If it's ionic, it's stronger. If it's covalent, it's weaker. Next is based on attraction forces. So if you look at the 3 types of forces, it's hydrogen bonding, dipole-dipole, and LDF. The strongest would be hydrogen bonding, which would be hydrogen bonded to a NOF. So let me write that down. H with NOF. Dipole-dipole is separation of opposite charges, and these are temporary. And then we have LDF, which are London dispersion forces. Now, LDF exists in every type of bond or compound. It is the weakest. So if nothing else is present, we say LDF. Also LDF, even if something is present, it's always LDF. Next, we'll move on to some terminology. The first one we have is En, the ability of an atom in a chemical compound to attract electrons in a chemical bond. So they have a tendency to want electrons. And the example of here that I'll give you is nonmetals have high En. Okay. Moving on, we have Ea. This is electron affinity. And the definition for this is energy change that occurs when neutral atom gains an electron. Okay. The example we have is metals. Metals, what happens is there's a small change, small energy change. And so we call that low affinity. Next, we have example nonmetal. Nonmetals have high energy change. High energy change or a large energy change, and we call them high affinity. Okay, moving on, next term is IE, which is ionization energy. Let me write that down again. Energy. So for ionization energy, the definition is it is the energy required to remove an electron from an atom. Okay, so example, metals have low ionization energy because they want to give electrons. They want to give electrons. An example would be lithium has 1 electron in its valence shell it's willing to give. And another example would be nonmetals. Nonmetals. So what happens with them? They have high ionization energy because they want to take electrons. Example would be fluorine, which has 7 electrons in its last shell, very, very, very high electronegativity and a high ionization energy. Ionic versus covalent. So look at your notes for ionic versus covalent in terms of bonding, melting point, boiling point. What are the differences? Can it conduct electricity? What type of atoms or elements are doing each of them? So take a look into that. And other than that, we have another characteristic is ionic versus metallic. Ionic versus metallic, and the type of bonding that they will do. So look up these terms. Look up their differences. Says, okay. And if they tell you something is unknown and you have to find out whether it's ionic, whether it's covalent, whether it's metallic, use properties. So properties to look for. will include melting point, boiling point, melting point, boiling point, and conductivity. So conductivity. So what conductivity means is does it have conductivity? Okay, let's just take that off for now. We'll do this another time. Conductivity. So these are the three properties that you have to look for. Conductivity is basically talking about, can electrons flow in a liquid form of these properties. And also remember that ionic is going to be mostly in solid form. Covalent can exist in solid, liquid, and gas form. Metallic are usually also in solid crystals. And metallic will be able to better conduct electricity and electrons compared to ionic. So the strength goes from metallic to ionic to covalent. And the last thing we have for today is let me just look into it again over here. The last thing I want you to focus on today is the periodic trends. So going down, we have atomic radius will increase as we go down the group, and atomic radius will increase as we go from nonmetals to metals. So to the left of the group, atomic radius increases. For electron affinity, electron negativity, and ionization energy, as we go across a period, these will increase. As we go from down the groups, it'll decrease, or if you want to say, as we go up from the bottom of the group to the top, these will increase. Metallic characteristic increases to the left and down. Non-metallic characteristic increases to the right and up. Okay, make sure you understand and can differentiate between these trends. Just the last thing on the boiling and melting points. If you are given compounds such as carbon dioxide, MgCl2, okay, let's put this out, and water. Remember that MgCl2 is ionic bonding. This is covalent for carbon dioxide, as well as covalent for water. Now remember, ionic is strongest in our case between the three of them. And then we have water and carbon dioxide. Water would be strong. This is due to having all three types of bonding. It'll have hydrogen bonding, dipole-dipole, as well as LDF, London forces. Carbon dioxide, however, will only undergo LDF because it has a symmetrical structure and the dipoles cancel out. There are no dipoles formed, so LDF, having only LDF, will give you the weakest. Okay, so yeah, keep these in mind, and hopefully the test is going to be a breeze for all of you. I'll just overview this one more time. So the chemistry review, families. Then we looked at double bonds. Then we looked at energy levels. Bonding versus lone pairs. boiling and melting points, follow periodic trends, follow bonding, is it ionic or covalent, follow attraction forces. Then some terminologies: electronegativity, electron affinity, ionization energy. Then the differences between ionic and covalent, ionic and metallic. Properties to look for when you're distinguishing if it's ionic, covalent, or metallic. Melting points, boiling points, and conductivity. Conductivity in terms of electrons, conductivity in terms of electricity. Okay, and yeah, so if you're distinguishing between which one has the highest or weakest boiling and melting points, look for attraction forces. Look for these type of forces: LDF, hydrogen bonding, dipole, and yep, that should cover all of it. Thank you so much. Hope you have an amazing test.